class, and welcome to our Chapter 6 final review. So the first thing that we're going to look at is powers and exponents. So we've seen powers before, powers and exponents. Those are the little numbers that are written there. So if we had any sort of number here, it's what's going to be written right there. So for example, if we had 2, and then it would have like a little 2 next to it, it'd be 2 to the second power, 2 to the power of 2, or 2 squared. Those are the different things that we could call that thing. It could also have a 3, which means 2 to the power of 3. 2 to the third. We could have it here with 100. That means 2 to the 100th power. All that means is when we see a number with that little baby number next to it, it means that we're multiplying our original number by itself that many times. So for instance, if I was to write this out, it means my number times, let's say this was to the third. It'd be my number times my number right there, if it's to the third. Now, first of all, if I was to write this down, I want to write this in expanded form. So, I have 7 times 7 times 7 times 7. Which one's going to be my answer? 4 times 7 or 7 to the 4th? So, which one here is going to be my answer? Hannah, what's our answer?
7 to the power of 4.
Yeah, look at that. She used a great word too. She used 7 to the power of 4. Exactly. 7 to the 4th, 7 to the power of 4. Whichever one it is this one. Hey, but now you're thinking, okay, that 4 times 7, that's got a good ring to it, you know. When we see that, I like to show people 7 to the 4th is when we're doing repeated multiplication. When we're doing this, it's just repeated addition. So 7 plus 7 plus 7 plus 7 is 4 times 7, or 7 times 4. Either way works. But we care about exponents. When we're multiplying our numbers together, when we're multiplying these numbers together, that's how we're going to get this little exponent right there. So as such, what if I had an exponent that looked like this? If I had 9 to the third, it's a terrible 3. How would I write that out? So everybody, and I want to applaud here, Nathan, Maddie, Rafi, Izzy, Dominic, Isis, Sophia, Jenna, Emmett, Carmen, Daniel, and Liana, everybody who wrote 9 times 9 times 9, and a couple of you wrote the words 9 cubed. Exactly. So this is called 9 cubed, or, as I could say, 9, and then we would use the words to the power of, and those are the words we would always use, and then whatever that number is. So here as we see it, we have our numbers 9 to the power of 3. So, this is 9 cubed. And I've talked about this before. Here's how you can kind of remember it. We learned about this in a section. When we have a square, we are doing length times width, right? Let's say our length is 9 and our width is 9. That's 9 times 9. 9 times 9, or 9 squared. And this shape is a square. So that's how we can remember that little square, that little 2 up there means a square. Hey, do you think that same thing holds true when it's a cube? Let's see. As I make my nice-ish little cube. Yeah, there we go, I think. Yeah. So if I have this, I have my nicest little cube. I got this bottom length, that's 9. I got this side length, that's 9. I got this up length, that's 9. If I want to make it, this is 9 times 9 times 9. 9 times 9 times 9, or 9 3D, or 9 cubed, because this is a 3D shape. 3D's cubed, 2D's squared. So that's how we see these. And then as you can remember, we don't necessarily see 4D or anything like that. But that's a good way you know. So as we know, it would be the number is written multiplied by this little guy right there. Like, not by that little guy, but how many times that number is written. So, for example, as we saw, 9 cubed is 9 times 9 times 9. 10 to the 7th is going to be 10 times 10 times 10 times 10. And then, because I'm lazy, I'm going to put times 10 times 10 times 10. 10 to the 7th. So that's how we do our powers and exponents. What if we had to solve powers and exponents? So now I need to solve them. 2 cubed, right there. Again, that means 2 times 2 times 2. Who would like to tell me what 2 times 2 times 2 is? So we got Emmett, Sophia, Madison, Carmen, we got Marcus, we got all of these. They say 8. So the answer is 8. So now that we know that one, I want you to think about this. 1/2 cubed. 1/2 cubed. Huh. We're still going to follow the same steps, though. The same steps. So we're going to do 1/2 times 1/2 times 1/2. So that should be a good hint. And then we just go about it as we know how to multiply fractions. As we see here in our answers, we got Dominic, Madison, Izzy, Daniel, Emmett, Ani, Marcus, Angel, who got it all right, and they got 1/8. Exactly, we're still following those exact same steps. When we multiply fractions, we multiply across like that. So 1 times 1 times 1 is 1. 2 times 2 times 2, just like we did it before, is 8. So great job. Some mistakes you might have made would be accidentally doing repeated addition. That is not cubing it. Then you would have gotten 1/2. Some mistakes you might have done was when you combine fractions, you just add them through there, in which you would have gotten 3/6, and or if you did it without adding all the way, you might have gotten multiplying across and adding the bottom and getting 1/6. If you multiplied the bottom and added the top, you would have gotten that 3/8. But when we're multiplying fractions, we multiply the top to get our new top. We multiply the bottoms to get our new bottom. And that is how multiplying fractions works. So let's try one more. I want to write this out. I want to write 1/3 to the 4th out. I want to write that. So again, is that going to be 1/3 times 1/3 times 1/3 times 1/3? Is it going to be 1/3 plus 1/3 plus 1/3 plus 1/3? Or is it going to be 1/3 times 4? So those are our 3 options for us. So let's pick. Is it going to be option A? Is it going to be option B? Or is it going to be option C? So is it going to be option A, B, or C? Yeah, everybody's telling me it is option B. Exactly. So when we're doing these powers, it means multiplication. Then, as we know, here's what I want to talk about a little bit next. So we want to talk about Pemdas, right? So I want to talk about that. So I want to talk about Pemdas. We hear it all the time, and we really need to know what we can and can't do with Pemdas. So first, I'm going to have you guys tell me, what does the P in Pemdas stand for? Daniel, what does the P stand for?
Parentheses.
Yes, it does. Excellent. So the P stands for T-H-E-S-E-S. Parentheses. Excellent. Which we also remember are those. Yes. In fact, parentheses do, by the way, include absolute values. Okay? Parentheses do include absolute values. What does the E stand for? What do we think the E stands for? The first one, let's see actually. Hannah, what does E stand for?
Exponents.
Yes, it stands for exponents, which was exactly what we are doing here. And our little exponent right there. So then let's see. Maddie, what does M stand for?
Multiplication.
Yes, multiplication. Let's see. And then Izzy, let me get you. What does D stand for? Izzy. Her screen froze. Dominic, what does it stand for? So Mike didn't work. This is funny. Exactly. It stands for, as we have it, division. And then we've got, as you guys have already written, addition and subtraction. Now, as I've also gone over before, and this is important to note, these two are the exact same, and these two are the exact same. So, when we're doing those ones, multiplication, division, and addition, subtraction, same steps. If we're solving PEMDAS, if we're solving with PEMDAS, then it's just whatever goes first. So it's left to right when we're solving addition, multiplication, or when we're solving multiplication, division, and addition, subtraction. So when we're solving in that order. So we solve with PEMDAS whenever there's no variable. So we use PEMDAS. This is important to know. Okay? We use PEMDAS when there is no variable. Do you think then, if I'm saying it like that, that we use PEMDAS when there is a variable? What do you think? If I'm saying we use PEMDAS when there's no variable, what do we think? So when we have a variable, this is when things get messier. So in this case, to solve for a variable, and this is silly, but we need to use, as I like to call, SADMEP, which is just PEMDAS backwards. So when there's no variable in our equation, when we have no variable, we use PEMDAS. When we have a variable, and our variable means something like X, Y, Z, A, B, C, any sort of thing like that, then we have to use SADMEP. And again, these two are the same, and these two are the same. These two are the same, and these two are the same. So that is exactly how we do it when we're solving for a variable versus when we're solving without a variable. So what if I had this problem? So here we're going to look at these problems. While we have variables, all we need to do is plug them in. Once we plug them in, there's nothing else that we can do. We don't actually have to solve for a variable. The variable's already been solved for. We already know the variable is equal to 4. We already know this one is equal to 1/3. So we're still just following PEMDAS. We plug it in, and then we solve. So based on that, what is the answer to number 1? What is the answer to a plus 8? Excellent. I got Emmett and Jenna, who answered to me that number 8 is 14. And Isis and Ani and Nathan added 2. What about the answer for the second one? A minus B. Yeah, we get 2. Because at this point, all we've done is we've just plugged in. Here I got 6. So I got 6 plus 8. Just counting, that's 14. Here I've got 6 minus, and then I take away 4, and 6 take away 4 is 2. So then what's the answer to that third one, which would be 6 times 4? Yes, it is 24. And then lastly, a kind of tricky one. What's the answer to the bottom one? What's the answer to the bottom one? So the answer to the bottom one is 3. We get that as we multiply 9 times 1/3. When we multiply, everything must be fractions. Anything is a fraction when you put it over 1. Anything is a fraction when you put it over 1. So when you multiply, you now multiply your new tops and your new bottoms, and you get 9/3. Or when you simplify that, you get 3. Again, we could cross off using greatest common factors. They have 3 in common. So it'd be 3 times 1 over 1 times 1 is 3. Great job. That's how we solve those when you plug in. That's all you do. What if I had one that looked like this? As Sophia reminds us, this is just plug and play. All we do is we plug in our numbers and we get our answer. So we see here, we use our variables at the bottom. We've got A, C, which means A times C. And then we add A, we divide by B. So first, if we did this, we follow Pemdas. We do what's in the parentheses first. We do what's in the parentheses first. Then, while we're doing that, first we do multiplication, then we do addition. Outside the parentheses, our next step is division. So, we're getting a lot of 2's. Let's see when we go back and fill it in. A times C. What that is 6 times 1/3. If I cross cancel, they both have a 3 in common. That means I get 2. 2 plus A is 6 equals 8. Then I'm dividing it by B, which is 4, and I get 2. I have a question for you guys. I had this. AC plus A divided by B. Does my answer change if I take away these parentheses? Is my answer still 2, or does it change when I take away the parentheses? What do we think? Rafi says change. Let's see. So even though this looks like variables, it just became plug and play. So if I plugged it, it was 6. And then I had times. I got this plus. I got the divide. I got plus 6. 1/3. 4. So if I took out the parentheses, it's either going to change or stay the same. So since I already found our variable, we've got no variables, we follow Pemdas. Parentheses, there are none in this new one. Exponent, there is none. Multiplication, cool. We got some multiplication right there. We need to remember multiplication and division are the same thing, so it does that. 6 times 1/3, we get 2. So now I got 2 plus 6 divided by 4. Then we got division. Cool, so I'm going to do that. 6 divided by 4. That's 2 plus. And then 6/4, once again, would simplify. 2. 3/2. And then if I'm going to add them together, and this one becomes 2 3/2, and if I wanted to make it a proper fraction, it'd be 3 1/2. Hey, wait, I don't think that's the same thing. Yeah, so when you take out parentheses, when you change things, even the slightest thing like that can change the order. So now I'm going to ask you guys, I'm going to give you varying examples, and you are going to tell me what step I do first. So if I was to follow Pemdas, which highlighter part would I do first? Would I do the yellow, orange, green, or blue? So would I do yellow, orange, green, or blue? I'm following Pemdas. Excellent. So we've established that first I do yellow. And I do yellow because it's in the front, right? Is that why I do yellow first? So Dominic and Hannah and Ani say no. Why do I do yellow first? Yeah, Hannah put out that there's the M, P-E, capital M-DOS, because we have no parentheses, we have no exponents. So now we're looking for that M. So then what color comes next? I'm going to guess that it's that orange, right? Because I got it all set up. So let's see what color comes next. Oh, wait, I'm wrong. Green comes next. Yes, because that's following our Pemdas right there. If we're following along, that's Pemdas. Now which step comes next, right? So now we've got addition and subtraction next. So I got some people saying blue comes next. What do we think? So Sophia, to reiterate on what Hannah did earlier, says it's addition. Pemdas with the capital A. So we go A first. That's what she says. Hannah goes, red is in first in order according to going left to right. So yes, Hannah is correct in the sense that we actually do this one first, technically orange. But we do that one first because, just like we remember from before, addition and subtraction are the same thing. So when we get to the same thing, when we're doing this, for these ones down here, we go left to right, and for these down here, we go left to right, just like we saw over here. Always go left to right, always go left to right here. So that one was a trick one I gave you on purpose. Not only do we need to pay attention to Pemdas, but we need to pay attention to the fact that these are the same and these are the same. Let's do another problem. So we got this problem. Now, as we already know, multiplication, division, and addition, subtraction, same thing. We always go left to right with those. So based on this, what do we do first? What's our first color here? So I'm getting a mix. I got a blue, I got the red, which is technically orange, but it's not the point. Exactly. So we're seeing this. What do we think? Excellent. So we get the red, technically the orange, first. Because even though multiplication comes first in Pemdas, it's just written first. Multiplication, division, same thing, left to right. So as such, the next one, as you guys wrote, is blue. Even though it goes multiplication, division, like I said, we go left to right. As such, what comes next? What color comes next after that blue? Yes, you guys are rock stars, yellow, because even though addition comes first, we're going left to right. But then, lastly, we have our addition. So, you always need to make sure that you're going in a specific order. Now, I have a question for you, right? So, I see this problem right here. I had 9 minus 3 divided by 2 plus 6 times 3. Now, I have a question for you. Did my problem change at all? I just put some little parentheses in. I just did some tiny bit right there. Did my problem change at all? Yeah, it did. Now this is tricky. What about if I did that? Did my problem change at all? I'm still getting some yeses. Funny enough, in this case it didn't, but simply because, actually, you know what it did? Because it's on the outskirt. If I was encompassing it, it would actually be that I would need, because I need to include whatever operation goes before the number. So again, a good refresher is, when I have my numbers, if I had positive x minus y minus z, the minuses, all of those, go to the numbers that are in after it, like that. We care about the operation that comes before the number. So, we have to make sure that whenever we're doing it, we include that operation in front of that number. Otherwise, it's different. Otherwise, it changes. So then, let's see. Here I want to simplify. When I simplify, I combine like terms. When I'm combining like terms, what that means is that the terms that look the same, the terms that look exactly the same, either with a variable or without a variable, can be combined. So now we have to start on the parentheses. But do the parentheses here mean anything? No. Because all we got is addition, subtraction. They don't matter. As long as we go left to right, the parentheses here don't mean anything. 14y plus x. Can I add things with different variables if I don't know what the answers are yet? No. I cannot add things. But what can I add here? I can add something. What are the things I can add in this problem? Yeah, so if you I can add my y plus y. So I'm going to rearrange it. I'm going to write 14y plus 22y plus x. Totally works. I rearranged my order. It's fact family. So, when I solve this, I get 36y plus x. And that's my answer. So I get 36y plus x. That's it. That's my whole answer. What if I had one that looked like this? If I had something that looked like 4, in parentheses, 2x plus y. I want to use a property. Does anybody know what property I'd be using here? So the property we'd use is distributive, in which case we're multiplying what's on the outside by everything on the inside. So I always like to draw arrows over it. So 4 times 2x, that gives me 8x. I'm actually going to make a change here. I'm going to make this minus y. And now I have minus, and then I have 4y. Great job. What if I had a minus 4 out there? I do that same thing. I multiply it, but minus 4. Negative 4 times 2x becomes a negative 8x. Negative times a negative becomes a positive. So all I did was multiply it by each one individually. What if I had this one? Let's do this problem. I want you to simplify. 3x plus 9y plus 2z plus 2x minus 3y plus 7. There we go. A nice big thing right there. So here's what we have. I want you guys to combine the like terms and write me my answer. Now, I know that if you just came back, let's say you're an alien and you just saw this, you're looking at this and you're going, okay, who just sprinkled some alphabet soup in my math class? But really, we're not solving for this. We're not getting a number. All we're getting is a simplified equation. So we're still going to have all those variables. We don't know how to solve for them. There is no way. There's no equal sign. They didn't tell us what the variables were. So we can't solve. All we have to do is simplify it as much as we can. So Jenna and Nathan both got it correct. Now, they wrote it different ways, which is totally fine too. So let's go over how they did it. I'm going to go first. Here's a 2, so I'm just going to color it a different color. Now, do I have any other just numbers on their own? Yes, I do. Right here, I have a plus 7. Once again, I care about the number in front of it. That's all the numbers I have. Now let's go back. Okay, here I have a positive 3x. Let's see what other x's I have. Up here, I have a positive 2x. Awesome. So I've combined those together. Now let's keep going. Ooh, here I've got a positive 9y. Okay, let's keep going. Up here, I have a negative 3y. Awesome. And then lastly, here, I have a positive 2z. Oh, I don't have any more 2z's. So now I'm just going to combine the parts that are the same color. 2 plus 7 is 9. Now, I'm going to write that at the end because I just like to keep my numbers at the end, but there's nothing wrong with however you do it. Then I'm going to combine my x's. I like to go x, y, z if I have them. Positive 3x plus 2x makes 5x. Now I'm going to combine my y's. Positive 9y minus 3y is positive 6y. Then I've got my z's. I only have one z, so it stays positive 2z. And all I did right there was combine the like terms. Combined the ones that looked the same. The last two things I want to go over is we did that distributive property where we had 4, 2x plus, we'll do minus y. We'll do a tricky one, right? So here when we did this, we got negative 8x plus 4y. What if I had something else and I wanted you to pull out and do the reverse of this? I want you guys 16x plus 12y minus 32. I want to simplify this. I want to get this where I pull a number out. So I want this to look like some number and then simplified versions of our x, y, and our number. What we're doing is we're looking for the greatest common factor between those, and we're going to pull out the greatest common factor. That's it. So, what is the GCF of 16, 12, and 32? So let's think. What is it? Nathan says it is 4, and he's correct. So just to make our lives easier, here, I pulled out a 4. So here I'm dividing by 4. To get out, I'm dividing by 4. And to get out, I'm dividing by 4. They all must have the same greatest common factor. Otherwise, we cannot do this. They must all have the same greatest common factor. So 16 divided by 4, we get 4. 12 divided by 4, we get 3. And 32 divided by 4, we get 8. There we go. These are the exact same answers. So when I have this, it's the exact same as that. When I have this, it's the exact same as that. They're just different ways to write them. After distributive property, before distributive property. Distributive property is called factoring because we use greatest common factor. The last thing I want to cover here is, what if I said this? I want you to write this as an expression. Ready? 2 more than G. 3 less than F. And 12 times E. I want us to write them. So, let's write that in expression form. So turn these words into numbers and operations. So turn these words into numbers and operations. Each one will still have a variable. I can't get an answer. There is no is this, equals this. So as Sophia wrote, and this is going to be helpful, she wrote G plus 2, and Nathan wrote 2 plus G. Who's correct? Who's correct? You're not answering me, but the answer is they both are. Same exact thing. It's addition. It can be written either way. Let's say G was 6. 6 plus 2 is 8. 2 plus 6 is 8. Same exact thing. You want to check to make sure you're correct? Make up a number and plug it into your variable. Make up, plug and play. 3 less than F. So I'm going to write F minus 3 and then 3 minus F. Which one's correct? So I wrote it the same way. Previously, as we did it, this is correct and this is correct. Oh, but here I'm only getting F minus 3 correct. As we see these terms, less than. Than means come after. So, than does mean come after here, but it doesn't matter because it's addition. But if you see than, sometimes it's always better just to get used to that. And lastly, 12 times E is simply 12 times E, or 12E. Either way works, 12 times E or 12E. That's all you do when you have here. That's what our answer is. There's no equals 7. There's no anything like that, but if I was given an equals 7, then I could solve for my variable. But if I don't have something that tells me what my variable is, if I don't have an A equals, B equals, C equals, if I don't have an equal sign anywhere, then this is the end that I get to. That's the whole thing. You guys did really, really well. Congratulations on reviewing Chapter 6.